First thing we need to be able to do to work with polynomials is simplify them. And doing that is built on this idea of what are called like terms. Like terms are ones that have exactly the same variable parts, including the exponents. It's the like terms that we're going to be able to combine together to make our polynomials simpler in the sense that they have the minimum possible number of terms. So let's look at some examples. When we're trying to decide if two terms qualify as like terms, I don't care about the numbers that are out in front, right? So I'm not looking at the 3 and the 7. I'm not looking at the 5 and the 10. The only parts that I care about are the variables and their exponents. So we look at this first pair, 3x and 7x. The variables here are x and x. Those are the same, including the exponents. So these two are what we would call like terms. Now looking at the next one, things get a little different. Right here, I have an x for both variables, but the first one has a different exponent. First one has a 2, where the second one has nothing. It's an implicit 1 up there. So these two are not going to be like terms, and I would not be able to combine these together to simplify an expression that they were in. Now the next ones, here we have a similar issue. There's more than one variable, and that's okay. We just have to compare both of them. So they both have this a, and that's great so far. But this one has a b where this one has a b squared. Right? That makes the variable parts different. So these two are also not like terms. Okay, and finally, down here we have xz squared and xz squared. Those are absolutely identical, including the exponents. So those are like terms. Okay, so how can we combine these things? How can we combine like terms to simplify an expression? Well, the example I like to give people is instead of the variables, right? Let's replace the variable with something more concrete. Say instead of saying 3x plus 7x, we said 3 apples and 7 apples. All right, so if I told you you had 3 apples and 7 apples, right away, just basic English, you know that you have 10 apples. All right, so notice what happened there. All right, the numbers changed. We just added the 3 and the 7 together to get 10. And the name of the object stayed the same, right? It was apples in both versions of the expression. We're going to do the same thing over here with the variables. All right, so when I have 3x plus 7x, I'm going to add the numbers together. And the object, if you will, the variable in this case, stays the same. So 3x plus 7x is just 10x. And I'll do the same thing down here. If these are like terms, these are the same expressions we had on the previous slide. So what I'm going to do here is I'm going to combine the 4 and the negative 2, and I'm going to leave the variable part the same. 4 plus negative 2 is 2, so this is xz squared. Right? That's how you do it. It's all there is to it. You add the numbers together, and the variable parts stay exactly the same as they were. Okay, so I've got a bigger example here for us to look at. I want to simplify this expression, and what makes it not simplified is I have multiple terms with the same variable part. So I have 2x to the 6th terms, and I have 2x cubed terms. And for this to be simplified, I only want there to be one term with each possible exponent. All right, so here's what I'm going to do to combine these, to simplify this. First, just kind of for the sake of clarity, I'm going to rearrange things so that the like terms are together. So I'm going to do 3x to the 6th minus 7x to the 6th. You notice that minus sign came along with it, right? Because that's a minus 7 out there in front. Plus 4x cubed minus 6x cubed plus 2x plus 2. There's only one x term, and there's only one constant term with no variable. So those are just going to kind of be along for the ride. I'm not going to make any changes to them at all through this whole process. So here, I can combine these terms together. This will be 3 minus 7 x to the 6th. And then I can combine the two together here, 4 minus 6 x to the 3rd plus 2x plus 2. And there we go. 3 minus 7 is negative 4, so that's negative 4x to the 6th. 4 minus 6 is negative 2, so this is plus negative 2x cubed plus 2x plus 2. And that's almost it, but we would never write this plus negative 2 here. So I'm going to make this negative 4x to the 6th minus 2x cubed, much more natural way to write that, plus 2x plus 2. And that's it. That's my simplified version of this expression. So not only is this idea of combining like terms useful just for simplifying expressions, it's also going to be the key component to adding and subtracting polynomials from each other.